Okay guys, we're back to more applications of linear equations. This one is what I'm going to call a motion problem. Hashtag motion probs. Okay, so for this one, we're going to have a formula. It's an important one. You're going to see it on the test. Rate times time equals distance. The rate of speed that you travel times the time that you travel for will tell you how far you went. So my process, my thinking about how to solve these is similar. You want to identify a variable. I'm not going to draw a picture this time. Instead, when there's formulas, I like to make tables. When there's a formula for the problem, I like to make a table to help us solve. And then we're going to use the table to make an equation. And then we're going to again solve and check for reasonableness. We're trying to find out in this problem how fast a bus goes. So when we check for reasonableness, we can say, hey, can a bus travel that fast? Or we'll think about it, because chances are if it's an unreasonable rate of speed for a bus to travel, then we made a mistake, okay? So we're gonna start with I'll read the question here. Let's see, Jeff can bike to work in 3/4 of an hour, and the bus takes 1/4 of an hour, and the bus travels 20 miles per hour faster than the bike. How fast is the bus? I know these are the types of problems that, you know, kids get nervous about. It gives them nightmares, I remember. But that's okay, it's gonna be all right. So we have two different vehicles traveling. One is a bus, one is a bike. And one's slower than the other. Which one's slower? The bike, right? Because it takes longer. It takes the bike longer to get there, almost an hour, where the bus gets there in 15 minutes. So we're gonna make a table. Our table is gonna include columns for our formula, and we're gonna say rate times time equals distance, okay? And we've got the bus, and we've got the bike, okay? Now, let's see. We need to identify a variable. I should have done that first, but a lot of the times the variable can be found in the question. It says, how fast is the bus? Well, the variable, or the question is asking how fast, meaning we don't know it's the speed. So maybe the variable can be rate. Oh, let's do that. Let's say x is the rate. We'll use x for our variable, okay? All right, so what I'm gonna do, I'm just gonna say that one of these two rates here, either the bus or the bike, is x. Let's say x here. Now, other information that we know of the problem is that the bus travels 20 miles per hour faster than the bike, okay? So if I call this x, how can I make, what would I do? Think of our word bank. What do you think 20 miles per hour faster than means mathematically an operation, right? I think it's add, right? I think it's gonna add, we're gonna add 20. And which one should I add 20? Which one's faster, the bus or the bike? The bus, right? So we're gonna add 20 to the bus's rate, okay? And now let's look at the times. The times we know are given. The bus took 1/4 of an hour, and the bike took 3/4 of an hour. Now, to get distance, you multiply rate times time, okay? So I'm gonna multiply 1/4 times x plus 20. 1/4 times x plus 20. And I'm gonna multiply 3/4 times x, okay? Now we need to make an equation. We identified the variable, we filled out a table, we're gonna make an equation. I got an expression for the distance here that the bus traveled and the distance that the bike traveled. Now when someone's coming to work and then they're coming back from work, or they're going to work on a bike or to work on the bus, tell me an assumption we're gonna make about the distances. It's gonna help us make an equation. you said it, they're going to be equal. So we will have one, I'm gonna make an equation that shows their distance being equal to each other. So I'm gonna say 1/4 times x plus 20 equals 3/4 x. And now I'm gonna distribute the 1/4 here. So I get 1/4 x, 1/4 times x, and 1/4 times 20 is 20 over 4, which is plus 5 equals 3/4 x. Now I want to clear fractions. What's the lowest common denominator that I can multiply by to clear all the fractions on both sides? Yep, it's 4. So I'm going to multiply this side by 4 and this side by 4. So 4 times 1/4 is 1x. And then 4 times 5 is plus 20. So I get, on the left side, 4 times 1/4, I get x plus 20. And then 4 times 5 is that 20 equals 4 times 3/4 is just going to be 3x. And then that's it. Now I can move all the x's to one side. Minus x, and then 20 equals 2x. I'm running out of room, I'm sorry. Wish I had a nice recording studio. And then I will divide both sides by 2, and x will equal 10. That is my answer. Oh, I'm gonna write it right here. X equals 10 miles per hour, okay? And let's analyze and check for reasonableness. Is 10 miles an hour a reasonable speed for a bike? Yeah. And then if the question actually asks us, how fast is the bus? So if I want to find out how fast the bus is, it's 10 plus 20, because that's the rate of the bus from our table, and our bus is 30 miles per hour. All right, this takes practice, and this is, we're just getting into these type of problems, so don't be scared just yet. We got this. We're gonna practice some in class to see what we can do. Proud of you. I will see you. Got another one coming. I'll see you soon.